Assalamualaikum and hello to my lecturer, Dr. Sharin Hazlim. I'm Siti Azmina binti Muhammad Masarik with matrix number A19EC0304. In this video, I'll be presenting my project 2 for subject probability and statistical data analysis. So without further ado, let's start. My project title for this project is How does the student performance affects the mathematics score among the students of secondary school in Porto, Portugal? For this project, this case study is regarding the statistical analysis of some factors that affects the student's performance in mathematics score. Such factors mentioned are extra paid classes, students' attendance, students' grades from Test 1, Test 2, and Test 3, which is also considered as the final grade of the assessment. The grade 3 is also considered as the final grade. In this project, the data set was, I get the data set from a platform called kaggle.com. This data set provides all the sample factors that relates to the student's performance. This collected data set involved 395 sample students from the population of secondary school students in Portugal. RStudio were used to complete this project. So in this project, there are 5 data type analyses were used. So the first test is hypothesis testing to sample. In this test, I used statistical inference for 2 independent sample, where I test on the difference between 2 mean, where with the variance known. So in this test, I've set the mean 1 as the sample mean of G3 score for students who attend extra paid classes, while my mean 2 is the sample mean of G3 score for students who do not attend extra paid classes. So my null hypothesis is mean 1 minus mean 2 equals to 0. My alternative hypothesis is mean 1 not equals to mean 2. I'm sorry, doctor, there is typing error here. This one should not be there. This is my R calculation for hypothesis test. Based on this calculation, I got my Z test value as 2.919866 and my Z alpha value is 1.96. So since the Z test value is greater than the critical value, we reject the null hypothesis at the 0.05 significance level. Therefore, I can conclude that there is differences between the mean sample of grade 3 score for students who attend and do not attend extra paid classes. Moving on with the next one, which is correlation test. For this correlation test, I've used variables such as students' absences to class and also the grade 3 final score of maths. And I did use Pearson's product moment correlation. For this, my null hypothesis is there is no linear correlation between students' absences and grade 3 score. And my alternative hypothesis is that the linear correlation exists between these 2 variables. Based on the results that I got, the t value obtained is 0.67933. Which is less than the critical value with alpha 0.05. Thus, we fail to reject the null hypothesis. Therefore, this is the scatter plot for the correlation between students' absences and grade 3 score. Therefore, from this scatter plot and the result that I obtained here, we can conclude that there is no sufficient evidence of linear relationship between students' absences and grade 3 score. From the scatter plot, the correlation coefficient value R is equals to positive 0.03424732, significant at the level of 0.05. From this, I can say that the linear relationship between both variables are very, very weak because the value of the correlation coefficient is very near to 0. Okay. My next test is regression test. For this test, I've used variable grade 1 and grade 3 students. The dependent variable for this test is grade 3, which is also known as the final score, while the independent variable, which is x, is the student's grade 1 score. So this is my hypothesis and my result. Here is the scatter plot of grade 1 against grade 3. The regression graph shows a positive linear relationship with an equation of y equals to 4.861250 plus 0.580659x. The value of intersection is 4.861250, whereas the value of slope coefficient B1 is 0.580659. Therefore, from this scatter plot and the calculation, I can conclude that there is a relationship between variable x and y based on the values calculated. This test also gives coefficient determination of 0.801469, and this can be considered as a strong relationship because the value is very near to 1. Proceeding to the next test, which is chi-square test. In this test, I've chosen students' gender and extra paid classes status to be tested. This test is conducted to find out whether there is any relationship between the student's gender and extra paid classes. As Dr. can see here, my null hypothesis is the extra paid classes is independent of the student's gender, while my alternative hypothesis is the extra paid classes is dependent of the student's gender. For this, I've used Pearson's chi-square test, and we can see that the chi-square value is 6.586, and the chi-square critical value, which is x square alpha, is 3.841459. So since the x squared chi-square test value is greater than the chi-square critical value, we need to reject null hypothesis. Therefore, I can conclude that the extra paid classes attended by students is dependent of the student's gender. And moving on to the last test that have been conducted, which is the ANOVA test. In this test, a random sample of 395 students from 3 respective scores, grade 1, grade 2, and grade 3 are selected. This test is conducted to determine the significant differences between the means of mathematics test score for 3 respective tests with equal sample sizes. I've used significance level of 0.05 to test this. So here are the mean score for the 3 tests conducted, as you can see. And here, mean 1 represents the mean statistics score of test 1. Mean 2 represents the mean mathematics test score for test 2. And mean 3 represents the mean mathematics test score for final test, which is grade 3. So my null hypothesis is mean 1 equals to mean 2 equals to mean 3. While my alternative hypothesis is that at least one of the means are different. As per the result, I got my f-test value as 1.587311, and my f-critical value is 3.003338. So since the f-test value in this test is less than the f-critical value, we fail to reject the null hypothesis. Therefore, there is sufficient evidence to claim that the different mathematics tests conducted for the students have the same mean score as in the null hypothesis. So that's all for the data analysis part. And for the conclusion, based on the findings through this analytical study, I got to know that main factor of achieving good score is in students' own effort of learning and studying. This is because the score of the students does not really be affected by the attendance and also the extra paid classes. In this case, even when a particular student were absent to class for more than 5 days, the student math score does not affect that much. Besides, the students' grade 3 score are mostly higher than the grade 1 score. So here I can draw a conclusion that most of the students manage to focus and do well in their final assessment. So in this project, personally had given me the knowledge on the importance of choosing the correct data set in order to conduct all the analysis tests. The progress of processing and analyzing the data was a bit tough for me, but with the help of lecturer, for sure Dr. Sharin, and also Google, I managed to finish up all my project well. So here, I would like to thank Dr. Sharin for helping me throughout this project by answering all my questions and doubts. So that's all from me. Thank you.